if you remember in this chapter, we were discussing direct digital manufacturing. We discussed some cost models, time models, and this is an example about these. We have a company, and this company is producing hearing aids, and they are using an SLA machine. This is the type of machine they are using, and there's actually the bounding box of the part is 15 times 12 times 20 millimeter X, Y, and Z dimensions. So they may have, do you remember the bounding box? They may have such a kind of an shape, and the bounding box of this shape, actually they should be touching, it should be touching the boundaries of it. The size of this bounding box is given here, and the volume of the product is 1000 millimeter cube or 1 centimeter cube, and the average cross section area is 45 millimeters square. The layer thickness for this part is 50 micrometer, and we have some support structures, but they're not as long as the height of our bounding box. It's less than that, it's 10 millimeters. So for 10 millimeter part of the design, we have support structure, and the layer thickness for the support structures is not equal to the layer thickness of the part. As you see, it's twice the layer thickness of the model. It's 100 micrometers. So the question actually is, how many, what will be the cost and what is the time required for the fabrication of such parts on this machine? So the volume is 1000 millimeter cube, but the bounding box is this much. So we need to consider the bounding box, since otherwise, if you simply consider the volume, then that might be an actually placing problem. You need to place these parts properly. They shouldn't be touching each other, and this is possible only with the usage of bounding box. These are other parameters. The diameter of the laser is 210 micrometers. The gap between the neighbor parts is 4 millimeter, and it's computed that on a platform we can have in maximum a 1393 number of products. So what is the number of layers required? If you remember, the height of our box is 20 millimeter, and the layer thickness is 50 micrometers. So if you divide it, you will see that we need to have 400 layers for the part, but we only need to have 100 layers for the support structure, since the length of the support is 10 millimeter and the layer thickness for the support structure is 100 micrometers, and that's why we have 100 number of layers for LS. And the scanning speed in average is 6,230 millimeters per second. And by using our equations we discussed in the previous slides, we can obtain the build time. Build time of how many parts? More than 1,000 parts is actually about a day, 25 hours. And what are the costs? Purchasing cost, operation, manufacturing, I think I forgot this L, but if you sum all these, and the whole cost is about more than 1,000 bucks. And the cost of a single product is less than a buck. You see it's 0.89 or 89 cents. And since we are producing this number of parts in this manufacturing, and it's very low, like very low cost for a single hearing aid. But the thing is that the company is selling these hearing aids in between $400 and $1,500. You see that there is a huge difference between the manufacturing cost and the selling price. Why do we have such a difference between the manufacturing cost and the selling price? Why there is a huge difference?
Transportation.
Transportation, capital investment, engineering, we have many costs, and that's why this number increases to at least 400s. We have the guarantee cost, lifetime cost. So since the customer may not be satisfied with the product, they will return it to you, and then you need to fabricate another one, then send the new one to the customers once again. So there are many issues, and this results in an increase in the selling price. We have equipment costs, materials, operations, some extra operation costs, tooling costs. Some of them are included in the price, but they're not reflecting the main costs in a proper way. That's why they add lots of money on the manufacturing cost. So what are we expecting from direct digital manufacturing in near future? Obviously, we will have some new applications. Since we know that additive manufacturing has some advantages over the complexity, over the customization, and that's why digital manufacturing, digital direct manufacturing will be using such advantages of additive manufacturing in the near future, especially for producing low number of parts. And even you can have some functional complexities in the parts. You may have components, some electronic sensors, some circuitry, some mechanisms. They can all be included in the parts. And we may have further material complexities. You may be printing 2 material, even 3 or more material at the same time, and they will be all present in a single product. And the aerospace industry is highly interested in direct digital manufacturing. There are many companies working on such additive manufacturing technologies. They want to use the output of additive manufacturing machineries directly in their aerospace products. And in considering the material compositions, it might be a good advantage, especially for medical and health industries. And you may have, as I said, customized product, and this is especially useful for communication and computing devices. In near future, you'll have all the parts customized for according to the needs of the customers. And we may embed various sensors into the structural components. Recently, for instance, I have read a news about turbine blades, the wind turbines. They are embedding some low-cost sensors to different regions of the blades, and with the help of them, they can detect the fatigue or any other cracks in a much cost-efficient way, and this will obviously increase the life of the whole wind turbine. So you will see such cases in near future, and they will be using additive manufacturing as not just for prototyping, but for obtaining the final products. Any questions, guys, about this chapter, direct digital manufacturing?
Hocam bir soru sorabilir miyim?
Yep. I don't know who you are, but you have just written your numbers. 2168995. Yes.
Sorry, ya şeyden dolayı kalmış hocam. Sınav için gerekliydi. Hocam bu DDM prototipleme için kullanmaya uygun mu? Ya daha çok kullanılmıyor ama.
That's the case, then we don't call it as DDM. We call it as rapid prototyping or printing application.
Application of AM diyebiliriz aslında.
Yeah, direct digital manufacturing is a kind of a concept where you use the result of output of your machines as the final products. So it depends on where you are going to use the output. If it's a prototype, then you cannot name that manufacturing, let's say pipeline, as a direct digital manufacturing. It's just a prototyping pipeline.